Good afternoon, ladies and gentlemen, and welcome to the Hyster demonstration. First of all, let us please introduce ourselves. My name is Emilio Vidal. I am the territory manager and big truck specialist for Hyster in Iberia. And on my right-hand side, we have Bouwe Everts, our global platform leader for big trucks. On the track, we have Rekena, who will help us with the dynamic part of the demonstration. I will please ask you to leave any questions you might have to the end of the presentation, as we will have more time. It will be an easy way for everyone to ask and for us to answer. I'm proud to introduce you our two new prototypes we have developed for the Sea Terminal project. On the right-hand side, you have the restacker. It's a dedicated laden container for 45 ton on the first row, as it says there, 31 on the second, and on the third row can reach 19 ton. This machine can lift 5 high or even 6 high. It's a compact machine, even if it doesn't look like. It's a 6.2 meter wheelbase machine that can easily maneuver within the 15 meter space that is normally left between the two stack of containers. Of course, this machine can do empty containers also, but for that, we have a better solution, which is this machine over here. You can come a little bit closer if you want. This is our empty container machine. It's a dedicated and laden or empty container handler. To this machine, we can handle 20, 30, 40, or 45 food containers, and we can fit 2 types of spreaders. This is a single handle spreader, so it can handle only one spreader at a time. You can see there are vertical twist locks over there. We'll hold the container from the side. Over there, we hold the container from the top. We have another solution, is a double handler that will be able to handle 2 containers at the same time. On a single handler, we can go up to 7 high dry containers or also high cube containers. From the beginning of the presentation, you have heard by now words like productivity, low cost of ownership, energy savings, carbon footprint reductions, and low emissions. We are proud to show you and to prove you that the solutions we have developed for the port industry will definitely have a significant and positive impact on all of those aspects. When we look for productivity in a machine, we look at 4 or 5 key elements. 2 of those are the ergonomy and the visibility. Please, when you have the time, have a look to the both cabins are exactly the same for both machines. And you would agree with me, as they have agreed, the stevedoring and this terminal, that with such a comfortable atmosphere, with an excellent visibility towards the forward, the back, and the top, any driver at any port and any terminal would definitely work on an efficient, productive, and secure manner. We have a broad range of develop and tested solutions, but more than that, we have the capability to work with you on a detailed and a specific customer solutions, as we did for the Sea Terminal project. Next to the things which are standard offerings to all the customers in the world, you might be now asking yourself, what is new? What we have introduced, what we've done different on these machines than the others? And what about if I say connected, efficient dynamics leading to profitable low emissions? That probably even confused you more. And some of you might wonder what is behind that and how we can actually implement that on those machines. I'm going to now pass you with my colleague, Bouwe Everts, who will go more into the detail of the specific we have done on the machines. And hopefully by the end of the speech, we'll have a better understanding of what is behind our statement. Please, Bouwe.
Okay, thank you, Emilio. So my name is Bouwe Everts. I'm a global platform leader for the big truck range. We develop the big trucks in Nijmegen in the Netherlands for all our customers in the world. And we're proud that we're able to participate in the Sea Terminals project. So the developments we have done within the Sea Terminals project can be summarized in one sentence. Connected, efficient, dynamics, leading to profitable low emissions. So what do we really mean by that? I will explain you. So it consists of three parts. First is the connected part, and that's the use of telemetry systems, collecting valuable truck parameters while the truck is in operation, and with that we can further optimize solutions specific for certain customers or applications. Second part is the efficient dynamics, and that's actually about improvement of several systems on the truck, such as right-sized engines, smart transmissions, on-demand hydraulic controls, and all these things influence the fuel consumption and energy needs of such equipment. Third part is profitable low emissions, and that is optimize and reduce total cost of ownership while still being compliant to the latest emission standards. So for both trucks, the developments have started with our 2015 model year trucks, which already comply to the highest and the latest European emission standards. So currently we are at level stage 4 emission standards, and for that we have incorporated right-sized engines, smart transmissions, and energy-saving systems. So these are compliant to stage 4, but emission standards started with stage 1, and from stage 1 to stage 4 there is already a 90% reduction of the toxic NOx and particulate matter coming out of the exhaust gas. So there are major steps already made, and these machines comply to that, which we deliver to all our customers globally. So on top of the already efficient and clean trucks, we have installed several new systems, both on the empty and on the reach stacker. And these are focused on reducing fuel usage, energy usage, and you might know that CO2 emission is directly related to fuel consumption. All the systems we're testing on these trucks today are already close to potential market introduction and are currently under review for how they can serve our current customer base on a short term already. Now I want to explain the main changes I'll make to the empty container handler. So it's moving the spreader at the moment, so it's using the truck, pretending to pick up containers. So this can pick up containers 6 or even 7 high. That's higher than what's being stacked here today. Main changes on this truck is, for instance, the start-stop system, smart transmissions, including freewheel stator and hibernate idle, all related to the powertrain changes. So normal, this engine is at 900 RPM, but already after 17 seconds it moves to hibernate idle, and that means a reduction of 200 RPM. You can hear it maybe. The engine is now more quiet, and with that we save fuel, less RPM, less energy consumption in the idle mode. After 5 minutes the engine will stop if the truck is not used, so that of course will save energy. And in a normal terminal operation there are a lot of cases where the truck is not being used and the operator is waiting for the next movement to do. So on this truck, but also on the other truck, we have developed a 2 drive mode systems. One is for high performance and the other one is for eco-elo, for optimized fuel consumption. Since these trucks are now connected to the SEAMS platform in the Maarten, developed in the Sea Terminals project, the SEAMS platform can actively switch these trucks from one drive mode to the other. So if the truck is not needed for the logistic bottlenecks, it should operate as economical as possible, and the SEAMS platform can actually decide remotely to do that. SEAMS platform can also switch off the engine to further reduce energy, and that will only happen if all conditions are rightfully and it's a safe situation to do that. So other developments are LED lights. All lights on the trucks are replaced by LED lights. These consume less energy and are much more durable. The trucks have tire pressure monitoring systems. So I can show it on the reach stacker. So here there are additional sensors on the trucks. Every wheel will have such sensors, and they give a signal into the system in the cabin, and that gives and on the display the driver can see if the tires on the truck are used within the optimal pressure range, and that should be the case because that is the best case for fuel consumption and wear. It will save tire life as well, and the cost of the tires are a significant part of the operational cost of these machines. So the less tires it consumes, the longer they take to replace them, the better it is for the cost of the operation. So what we said, we installed telemetry system on this truck, and there are two things. One is the Hyster tracker, and with that the truck critical parameters are being monitored. And within the operation, terminal operation, remotely, they can already check how the truck is performing, how many hours it's doing, fuel consumption. All these parameters can be reviewed remotely. And with that, the terminal operator can manage their fleet much more efficient. So if all the equipment here in the operation would have such systems, they can see how efficient they're using their machines and their equipment. It's also providing information on maintenance needs, any fault codes, so the condition of the truck. Next to the Hyster tracker, a second telemetry system is installed within this project, and with that we collect all parameters of the truck. And with that we get a very detailed insight how the trucks are being used, and with that such data set we can further optimize and adapt the systems we are implementing. When we're measuring the number of containers being picked up, how high they're stacked, the size of the container, and all these numbers are essential to calculate cost per container moved. And actually that is the most valuable piece of information for the terminal operator to understand how much the cost is within his terminal. Okay, and move on to the reach stacker for the laden containers. And I'll explain some innovations on this truck specific. So it has the LED lights, it has the tire pressure monitoring system as well. We tested different systems on both of the trucks. And this truck also has the 2 drive modes. So the high performance for maximum power and the eco-elo modus for maximum fuel saving. Next to that we have a new 5-speed transmission in it. It's very economic, very powerful, very little wear, lock-up clutch functionality in it. With that we see that we can reduce the maximum RPM of the engine by 200 RPM. And with that we save of course fuel, cost and CO2 emission all in one. But next to that this is of course part of the project, saving fuel, saving energy and CO2 emission. But with the reduced engine RPM, we also reduce noise for the driver. So it also makes the operation for the operator more comfortable. Now you can see the truck has stopped. 5 minutes has passed by, so if there's no need to move the truck, it will stay in this operation. If the driver wants to use the truck again, he moves the joystick, and automatically the truck is ready for use again. It's a bit similar to maybe some have experience with start-stop on your personal car. It operates the same way. But of course it needs to comply to a lot of safety regulations because there's very much different use of this truck. So we're now reviewing how such similar systems can be used in container handler as well. So I move back to the reach stacker. So here at the back you have the steering tires, and within the steering tires we have implemented a new system, what we call electro-hydraulic steering. And what it helps is to reduce rubbing of the tire. And if the truck is at standstill and you turn the wheels, it will rub and wear the tires out, which is very costly. So with this system, it helps to prevent that the driver is actually moving the tires when the truck is not or hardly moving. So this truck also has the telemetry system, duty titles collection, and we've seen these trucks are in operation here in this terminal since September. This truck has run more than 600 hours. This machine has run over 250 hours, and we're collecting a lot of data which we can compare to our tests we've done in-house in our German test facilities, and we see similar fuel consumption numbers here in the field test as what we've tested here. So with that, we are confident that we can meet our project goal, which is a reduction of 25% fuel saving if you compare these machines with stage 3A previous emission standards. So we're confident we're able to meet such fuel reductions. So we do realize we cannot show everything and explain you everything, so we're open for further questions after the presentation. But we can already say that we are very happy we have been able to work with a very motivated group of partners. We're happy that we're in the project with Maarten Terminal, with Port of Authority of Valenciaport. So these are all very productive partners, and we've been able to test real life in this site some new technologies, some innovations, which are based on the intelligent use of information systems. Okay, thank you all. This is the Hyster presentation. We move to the Terberg.
For the Terberg presentation, we can move to this area. My name is Maarten van Brink. I am representing Terberg. And we at Terberg, we are a manufacturer of terminal tractors, which are used for horizontal transportation on container terminals, moving containers over the yard. Here on behind me, we have two examples of our terminal tractors. In the left corner for you, we have a diesel truck, which is here for comparison. And behind me is our prototype of our electric terminal tractor. To start with the diesel truck, we have, of course, a fuel tank, which is mounted on the side of the vehicle, on the right side in this case. And behind the cabin, of course, we have an exhaust. This is already the exhaust system for Stage 4 legislation, which is the latest legislation currently in Europe. And underneath the cabin, you can actually see the diesel engine installed, and the engines, they actually get slightly bigger when we get new legislations. So there's very little space underneath the cabin to install. If we compare that to the electric tractor, on the electric tractor we have, but first we notice on the side there is no fuel tank anymore, which has now been replaced by a battery. Which is in this steel case, is completely filled with lithium batteries, and there's one case on each side of the chassis. Then behind the cabin there is no exhaust. The vehicle is completely zero emission. No exhaust gases coming from the vehicle itself. And then underneath the cabin, where the engine was at the diesel truck, we now have only the inverter, which is driving the electric motor. And the motor itself is actually below in the chassis. It's quite low. It's a lot smaller than the normal diesel engine would be. It's about 70 centimeter in length. Then in comparison, if we start the engine, we can hear the diesel engine running. It's the diesel knock, as we all know them. And if we rev them in operation, we can actually hear that the sound that the engine is making. That's another of the bigger differences of these tractors. In a moment we can actually hear the electric tractor as well. It's a lot more quiet. It does have an idle run still, but the idle run is there for the hydraulic system, because once the driver is using the hydraulic system, when he will activate it, he still needs to have power immediately. So as soon as the driver will get in, we can actually hear this. a bit quicker. Yeah, and now we hear the motor idling. We can hear the motor rotating, and we also hear a higher pitch, and that's actually the inverter, which is actually directing the energy to the drive motor when the driver asks for it. So that low noise level, that's actually one of the positive feedback that we got back from our trial here at Maarten with our prototype. We actually heard that for the drivers, they've experienced it as very comfortable. It's very quiet inside the cabin, and also the vibration level is very low compared to the diesel truck. Also, one of the feedbacks that we received is that the drivers were actually able to complete a full shift of 6 hours in the terminal, and after the 6 hours they needed to charge the vehicle. Well, with the vehicle we supplied it with a 40 kilowatt charger, and they were able to charge it in 4 hours, completely from 0 to 100. From there, actually, we took a lot of that experience from Maarten, and we tried into improving the product as we have it now today. Increasing the battery storage capacity is one of them. So we have great possibilities to have an additional battery pack to actually increase the driving range of the vehicle. And also what we have done is we have increased the charging capacity as well, so we can charge the vehicle a lot quicker now. So from there, actually, from that development, we actually designed a new production series of the electrical terminal tractor, which is now enrolled into the market at this point. And yeah, it's already available in the market. That was my presentation. Yeah, if there are any questions, then you can come forward and have a look at the vehicle, and maybe we have some time to answer some questions. Thank you.